Will they just shout them out? Will they be in a chat?
I love it. Yes, we've kicked off the recording. Amazing. We are here, episode 5 of the Defender Expert Star Forum. And we will be chatting with Christine Fonseca about some pretty interesting stuff focused on macOS, but more broadly, key considerations to keep top of mind for developing and honing your Defender skill set. And to Christine's point, she asked a very important question here. How can participants engage? Because we've deactivated the microphones as well as the chat functionality. No memes today during the session, but feel free to reach out, follow up with your top meme of choice. That said, we do ask you to leverage the Q&A module. We are responsive and we're ready at the helm to provide you with answers and additional resources as needed. We will be providing the recording as well as the slide deck after the event. We do have a very brief post-event survey that we ask you to complete. It is literally about 3 minutes, so please do take the time. Again, that is how we get all of our wonderful speakers from Microsoft Security Research to join us, and that's how we're able to curate topics. I see a hand up. Go ahead and feel free to post your question in the Q&A module. So I will be progressing in the slide deck now. Now, if for any reason you do not see slides on your screen, I happen to see slides. I believe my co-host, Samantha Gardner, as well as our presenter, Christine Fonseca, can also see slides. If by any chance you are not seeing slides on your screen, if you quit Teams and rejoin, that should resolve the problem. But again, feel free to reach out to me directly, Ray Wolfram at Microsoft.com. We'll help get you the access. And if nothing else, you'll be able to get that deck to follow along. So that being said, I am Ray Wolfram. I am a senior product manager for Microsoft Security. I am joined by my co-host, Sam Gardner, who leads North American operations for Defender Experts, our first-party managed service. And we are here today to unveil episode 5 of Defender Experts Star Forum. This is a technical-focused webinar series. No marketing fluff, no, here's how this functionality works, and let's talk to your account team about it. This is the real deal, exclusively focused on all the stuff that'll make you sharper and more effective. Hopefully by the end of the session, you can take it and apply it to your role today. So with that being said, again, we have kickoff. Well, Christine's going to lead us because it's quite an interesting topic. We have the discussion of our deep dives. It's going to get pretty technical. Again, if you have any questions, please do leverage that Q&A functionality. And then in terms of how do you get the slides, how do you get the recording, please do submit that 3-minute survey. You'll be able to access all of the collateral, all of those resources as soon as you do. Sam, do you have anything that you want to add before we dig right into it?
Enjoy, stay curious, and we're here to support you.
Amazing. And yes, and please, with the Q&A, do ask your questions. We will follow up. I don't see any posted yet, but please feel free, reach out, any questions, even if you can't see the slides. We will respond there. All right, Christine. And look at that. What a heck of a banner we've got going on for you there, Christine.
Awesome. All right. So I will take control of the slides now. Awesome. And then I'll try to keep an eye on the chat too. But if I go too long without seeing someone's question, just feel free to let me know. All right. So thank you everyone for coming. This talk is TCC Later, Spotlights Metadata Mischief in macOS. And so this presentation is actually going to cover a TCC bypass in macOS that me and my team found. So we found this exploit in February 2025. It was patched in May 2025. So what was really interesting about this was it was a macOS exploit of TCC, but because TCC is a mechanism that's applied throughout macOS, iPadOS, and um, iPadOS, so all three of those operating systems, we actually got a CV for all three of those. So it's really, really cool. All right, and so just to give you a little introduction to me, my name is Christine Fasasica. I'm a senior security researcher at Microsoft. And I've worked on a variety of different projects. I've worked on Defender for mobile, Defender for macOS. I've contributed to Security Copilot. I've contributed to Microsoft Threat Intelligence. Um, and I found the CVE with two amazingly talented, incredible coworkers. Jonathan Barr or his nickname JBO. And I like to say that everything JBO touches turns to CVE, so kind of the King Midas of exploitation. And then Alexia is not only an amazing security researcher, but she's also just an incredibly talented engineer. She's written a lot of code that actually feeds right into the MD engine. And she's really another just macOS expert. So love working with both of them. All right, so in this presentation, I'm going to give you a quick background into like what TCC is and what entitlements are, because that's very important to understand when I'm explaining the exploit later on. Then I'm going to give you an overview of Apple Intelligence, and I'm going to talk about sensitive data leak implications of Apple Intelligence and just other sensitive data, which ties in to our exploit. Then I'm going to talk about Spotlight and past exploits of Spotlight. I'll give you an explanation of our exploit and, of course, a demo because everybody loves a demo. And then I will leave you with some detection opportunities. I have a couple of sample detections for you and then also takeaways. All right, so jumping into it, what is TCC? So it stands for Transparency, Consent, and Control, and it's a macOS mechanism that's supposed to govern the permissions for accessing sensitive data. So sensitive data in this case is considered to be things like access to the microphone, access to the camera, maybe access to different files like your desktop folder, your downloads folder, location information, iCloud information, calendar information, screen recording, and more. So if you're a macOS user, you've probably seen this before. If you open System Preferences, Privacy, Security, and Privacy, and you see that there's all these little buttons that can be toggled, and that's actually how TCC is managed. So oftentimes, if you're like maybe writing some code or doing something, you'll see this pop up and it'll say, terminal wants to access your documents folder. And this is TCC. So when you click OK, you are changing TCC in that moment. So TCC itself is actually controlled by the TCCD daemon. So this TCCD daemon will edit the tcc.db, which is a database, and that handles all of the TCC permissions for all of those things like location access, camera access, microphone access, etc. So you can't control this. This is what's the underlying system daemon running on your machine. And so there is a per user TCC database as well as a system-wide TCC database. So the per user database requires full disk access to read and write, and certain types of TCC permissions are stored in that per user TCC DB. And then a system-wide TCC database, which requires full disk access to read, but you actually can't write it because it's protected by SIP. So even if you have root access, if SIP is not disabled, that cannot be modified. And again, these are only supposed to be modified by the TCC, the daemon. So a TCC bypass is essentially when you're able to access some type of sensitive information and you are not getting this pop-up and your TCC is not protecting that information that's supposed to be protected. So our exploit, if you look in the notes of it, it says that it's a data leak, and that's we were able to bypass TCC by leaking that information. So JBO is really talented in finding TCC bypasses, and he brought me and Alexia into this and taught us a lot about how TCC bypasses work before we went in and started looking for our own TCC bypasses. And he likes to separate TCC bypasses into two categories, complete and partial. And I thought this was a really great way of explaining it. So this is how I like to explain it to other people now. A complete TCC bypass is when you're gaining you get arbitrary access to most or all TCC service types. So access to the microphone, access to the camera, access to calendar, access to location. Those are all separate TCC service types. But if you can override like all of TCC DB, then you're getting access to all of those arbitrary service types. And so there's back in 22 a CVE that Microsoft had found called, we called it PowerDir, and that was considered a full TCC bypass because we had arbitrary access to all of those services. A partial bypass is when you can only gain access to like one or maybe a couple TCC service types. So maybe you like only get the location data or only get documents folder or only get camera access. Um, and so for this TCC bypass exploit light, we only have access to four different TCC services. So because it's not arbitrary, we can't add additional TCC services. We consider a partial TCC bypass. All right, so now I'm going to get into entitlements, and this ties in very closely with TCC. So Apple uses another privilege mechanism to govern data access, and it's called entitlements. These entitlements are supposed to be tightly coupled with a binary's digital signature, meaning that if the entitlements are forged or changed in any way, it's supposed to invalidate the signature on that binary. Now, there's definitely been bypasses in the past where entitlements are able to be forged or injected or changed. But that is kind of the underlying mechanism. It's supposed to be tied to the digital signature. So these entitlements govern permissions to specific operations that binaries are allowed to complete. So this would be like if you're an app developer and you want to call out to the internet for something, you can't just do that. You actually need an entitlement. So you use com.apple.security.network client, and that will enable you to have outbound network connections. Similarly, you aren't supposed to just be able to select and read and write files. um, Again, there's another entitlement for that. And so third-party developers are allowed to use these public entitlements to add functionality to their apps. However, there's also private entitlements. And so private entitlements are supposed to only be used by special partners or used by Apple. Um, and so they're not supposed to be used by third-party developers. And so some examples of that would be com.apple.system.passports or com.apple private TCC allow. And these are generally used by system level binaries. Only like Apple binaries are allowed to use these. Arbitrary binaries aren't supposed to be able to use these entitlements. Another example of like a special partner entitlement would be the endpoint security framework entitlement. So each endpoint security tool, such as Defender, has its own entitlement given to them specifically by Apple that only they can use. So we have our own endpoint security framework entitlement, and then our different Defender binaries are signed with those, and nobody else is supposed to be allowed to use that binary or that entitlement for their binaries. So notice I said com Apple private TCC allow, and you're thinking, okay, you're talking about TCC, and this is where this ties in. Um, so there are TCC specific entitlements. And when you see exploits against TCC, it's going to focus on binaries that have these TCC specific entitlements because you can't just like steal the TCC entitlement, write your own binary and say, oh, like I'm using Apple private TCC allow, and now my binary can do everything. So instead, threat actors will target those binaries because it has those TCC specific entitlements. So those two special entitlements are the TCC allow one, and then also Apple private TCC manager. So as an example, Safari, which is an Apple system level binary, that has some TCC specific entitlements. And so this means that when Safari is trying to access those sensitive um, services, it's not going to have any checks. So you can see here, and what I'm going to do actually as well is just zoom in a little bit so it's a little bit easier to see. Um, but like the address book, camera, the microphone, screen capture, things like that, those all don't have TCC checks because of the TCC entitlement used. So now hopefully when I go to the next slide, it zooms out perfect. Okay, so now you have an understanding of the Apple specific mechanisms related to the exploit. But before we get into Spotlight, I'm going to tell you about Apple Intelligence. So Apple Intelligence is a personal AI system that was rolled out this year and it's integrated into iOS, macOS, and iPadOS. And it's supposed to be like your digital personal assistant to make everything more convenient for you in everyday life. So it gives you writing assistance and like mail and notes. You'll get like reply summaries. So like especially in your iMessages, you'll get summaries of messages that somebody sends you along thread, or if you like haven't been looking at your group chats. You can look through photos in natural language, which is really cool because it makes it easier to search through photos. If you get a voicemail, there will be audio transcription and actual like summaries. Another thing that I've seen on macOS for Apple Intelligence is if you like lock your computer and you get a bunch of notifications, when you come back, you actually see those notifications summarized for you. So, um, because of all of these different features, summarizing all of these things for you, it has on-device processing, but this requires a lot of caching. So this means that the data is going to be stored somewhere on your machine. So for example, photo tagging data is cached in files. And when you think about, your pictures might be sensitive because you have like screenshots of company proprietary information, your emails, all of those things. Um, Apple knows this, so this is TCC protected. So not only is that data TCC protected, but the cache of that data is TCC protected. And I just saw somebody ask, is there a write-up or article that demonstrates an attacker abusing TCC entitlements on a Mac? Yes, so there's a blog post about this exploit. We actually have a bunch of blog posts, so we can definitely link those for you. So I want to dig more into the photo tagging because what we've seen with Apple Intelligence is it's extending the initial like Apple photo metadata information, and it's actually enriching and enhancing that data in new ways. So as an example, with this picture of me and my dog previously before Apple Intelligence, was rolled out, there was already some really cool mechanisms like face tagging. So all my photos of my face and then like pet face tagging Apple could do. But now that data is enriched, so now it goes even deeper. So you can see that it actually accurately identified my dog's breed, which is really, really cool. Because she mostly looks like a boxer, but she actually is mixed with Mastiff. So it's just really, really cool that it could do that. But it also makes you think about the privacy implications of that, because especially when it comes to company proprietary information or personal information. If you're traveling, you might take a picture of your passport. If you take a picture of your credit card for some reason or other things, now with this enhanced photo tagging, you're able to search through images in natural language. So that means that it's a lot easier for attackers to kind of collect metadata on your private files as well. So it's something to keep in mind. Um, and so Apple Intelligence maintains a variety of different databases, and some of these things too change across operating system versions, but Photos.SQLite seems to have kind of like the most juicy, sensitive information. So there's geolocation data, the photo and video metadata, which has that like locations and sometimes not even just the lat long tags, but it will go out to the internet and say like, oh yeah, I know this is in Spain or I know this is in Korea, and then it will actually give that information as well. Uh, recognition data, user activity and event context, your search history, stuff like that. And something else from a privacy perspective to remember is this data is synced between devices based on your iCloud account. So that's why it's really important not to share your personal iCloud account with like your work computer, for example, because you don't really want your personal files going onto your work computer. You definitely don't want your work files going onto your personal computer or your personal phone or something like that. So just really important to think about those things as well. Um, and so going into some of that data that you're going to see in Apple Intelligence is the lat long information. So in a picture of your cat, like there's a description, and maybe that's because it was from social media or something. But then the lat long. So this is, if you know lat long, you can see that we actually redacted this information, and this is because we don't want people showing up at JBO's house or something. But this is exact latitudinal and longitudinal measurements that's in this information that Apple Intelligence now has access to. Um, Additionally, it's a little hard to see here. I think I can zoom in, but your Safari browsing history is something that can be accessed. Additionally, because it does summaries of your iMessages, uh, iMessage content is now also able to be accessed. So this is like, decrypted iMessage content. Additionally, sorry if you can hear my dog taking a drink of water. But additionally, so um, email content itself is not being stored in a decrypted state, like the iMessage content. However, Apple Intelligence does summarizing of message content for you. So those summaries are not stored in an encrypted manner. So even though maybe the email itself was encrypted and maybe it's like, company confidential, but the summary of that is actually not encrypted. And again, lat long, it comes from a variety of places. So we showed that it was tagged in photos, but it actually is also stored in weather data. So if you look at this weather information, again, lat long is there. And so why is all of this metadata that I'm talking about important? And that's because that's the type of data that's supposed to be TCC protected and is able to be leaked when you have a TCC bypass. So now I'm going to dig into our exploit, and I'm going to show you how we used Spotlight to leak some of this TCC protected data. So Spotlight is an indexing service on macOS. And so this allows you to search through files based on the file name or the file content. And so if you want to do it through the command line, you can use the MD find tool. But most people just do command space and then they just start typing. And that's the easiest way. And maybe you didn't even know that this search mechanism is called Spotlight. So something that it does is it will start suggesting things for you. So if you just type in POC, it will start looking up maybe locations near you or things that it thinks that you're looking up. And then it will show you documents on your machine that have POC in the title. But you can see down below that last document doesn't have POC in the title, and that's because that document has POC in the contents of it. So that's just kind of showing the power of Spotlight, and it really is able to dig through all of your data. So there has actually been so many Spotlight bugs and research in the past. Even going back 10 years ago, there was a presentation at Black Hat that showed that Spotlight was able to leak information. Um, and our research showing how Spotlight could be used to leak Apple Intelligence was actually shared by a really prominent security researcher, Patrick Wardle. So that was really awesome that we were highlighted. So Spotlight is an Apple process that is very IPC heavy, has a complex design. I think a lot of Apple processes are designed this way, almost like each binary is an instrument and they're this composed of this orchestra and they're playing, and this is how they interact with each other because they're all doing different things and playing a part in how everything works. So these binaries are MDS, which is the metadata server, and that's like the coordinator. So this is the initial process that's spun up, and that calls and invokes these other processes. MD worker and MD worker shared is the actual indexer. So this is what goes through and indexes and parses these specific file types. And this is a sandboxed function. MD worker share is also sandboxed. Once the files are indexed, they're stored in Spotlight v100 files, and these are supposed to be TCC protected. And so the way that they can be accessed is if you get full disk access, which remember is one of those TCP services, and if that's granted from root, then you can access the Spotlight v100 files. Of course, Spotlight D is a newer binary, but that's what's feeding Spotlight knowledge into Siri and Apple Intelligence. And then if you want to interact with Spotlight, you can use MD-util, MD-import, or MD-find. Also, just going to zoom in a little bit here so that you can see. This is what the Spotlight V100, where the Spotlight V100 files are, and it's kind of what it looks like. So you can see there's all these different database files, and this is just kind of the directory structure for that. So Spotlight needs to know how to index these files because it's basically a parser of all of this different metadata. And there's so many different types of files. So instead of writing some like universal parser, it's just built around plugins. So there's different plugins for each different data type. So these plugins are macOS bundles with a MD importer extension. And so you can find Apple's specific ones, their built-in ones in system library slash spotlight. And so that is, SIP protected and everything. But you can see for applications that has its own plugin. So that's its own Spotlight parser. Archives has its own MD importer, so its own Spotlight parser. Audio files has its own parser. So if we wanted to make our own parser, because we decided that we wanted Spotlight to be able to better index, docx files, Microsoft could write their own plugin as well. But that would be stored in a different area. And I will talk about that. So MD worker shared is, and the MD worker binary, those are the binaries that are indexing these files. And because they're doing the indexing of these, Spotlight V100 files or of the Apple Intelligence data, or it's indexing your photos, all this TCC protected data, that means that they need to have entitlements to access those TCC services. So as an example, MD Workers Shared has KTCC System Service Policy All Files, which is full disk access, and all of these other things. So you might be thinking, okay, well, if I want to be an attacker and I want to exploit this, I'll just like hook MD Worker Shared. But no, the way that Apple is able to prevent you from, hacking MD Worker Shared is that it's heavily, heavily sandboxed. So MDS is launched, and then that launches MD Worker Shared. And so MD Worker Shared can't read files unless those files are passed to it using XPC. It can't just arbitrarily start reading files on your machine. Even though it has access to those files, it can't arbitrarily start doing it because it only can be files passed down through the Spotlight functional process. It also doesn't have network access, so you can't, as an attacker, hook into MD Worker Shared and start like trying to upload things to the internet because it doesn't have that access. You're not able to fork. So it's really, really limited. So Spotlight's limited because it's accessing all the sensitive data, and they really tried to lock it down. And you can see if you look at the sandbox profile, which defines how it's sandboxed, you can see all of those rules outlined here. So this is the MD worker sandbox profiles. And then, like as an example, more sandbox information. So you can see it's read only. You're not supposed to be able to write out any information. So that is what makes it hard to actually like leak from there. So now I'm going to zoom in again so you can see a little bit more. So if we look at the entitlements of the MD worker shared binary, you can see, first of all, there's no flags here. So that means that there's no hardened runtime on this binary. And then you can see what Spotlight TCC services are accessible. So you can see that the address book, calendar, reminders, and service system policy, all files, which is full disk access. So this is all of the TCC services we have access to. So in this exploit, that's why we have a partial exploit, because we couldn't add to this list in any way. We couldn't like inject code or anything to add to this list or expand this list, but we're able to access this information. So, like I mentioned, you can write your own plugin. And so, again, like we as Microsoft could write our own plugin for parsing, like maybe docx or PPT files or something like that. But anybody can write a plugin, even a malicious actor. And so something to note is this does not have to be signed. This plugin does not have to be run as root. And any third-party plugins are just placed under Library Spotlight MD Importer. Or library spotlight, and then your file, which is name of file .md importer, is stored in that. And so this was basically like the crux of the exploit. We've stored our own custom plugin, and we saw that it was leaking data where it shouldn't. So now I'm going to explain how you can code one. So like I mentioned before, Spotlight actually has been exploited multiple times in the past. And a really awesome security researcher, Chaba Fitzel, actually has a prototype for writing a custom plugin for Spotlight. And he showed that you can use Spotlight as a persistence mechanism if you are writing some kind of malware. So we leveraged this. And so in order to write your own custom parser, because your plugin is just going to define how the data is parsed, we had to edit 3 files in this prototype, and that was it. So there's 2 metadata related files, and that's info.plist and schema.xml. And this is basically declaring the types of files that the importer is going to intercept, because your Spotlight plugin is just going to run through all of these different files, and it has to know what the data types are. So you're going to edit those 2 files to say, hey, I want pictures, or hey, I want text files, whatever it is. And then you actually have to say, once you have the data and it's of this defined type, this is how I want you to parse that data. And so the way you define your parser is you implement get metadata for file, and you tell it how to parse that information. So because we were able to create this exploit, we were able to prove that sandboxing of MD worker, MD and MD worker shared is not sufficient. Um, because even though we don't have network access, can't fork, etc., you still get read access to the file, which means by reading it, you can then potentially leak it to other places. So we chose to leak to the standard log. So this is actually like the bulk of the exploit, and it's almost silly how easy it is. We were making jokes like, oh, we just can use Copilot to write most of this because it's so simple. And so this is the get metadata for file function. And so you can see all we did was we defined a path to the file that we want to parse, and then we calculate the size of that file. And so when we originally wrote this, we did not have the second portion that did this chunking. And this was because when we wrote to the standard log, originally it was just like, hello world, like I'm the exploit. And it leaked to the log and we were like, okay, cool, we did it. And then we tried to leak photo files and we noticed that nothing was writing to the log, and it's because the log was truncating that. So we had to chunk this data into 40 byte chunks. So now anytime it parses a file, it automatically chunks that and then it will leak it in chunks. So, but there's still two things missing because we have to define that schema.xml and that info plist file. Um, So I'm going to talk about that. And then, of course, triggering this is something that's a little bit harder because normally Spotlight will automatically run your plugins, but it doesn't necessarily do it on your schedule. It does it on the system schedule. So we're able to force the invocation of our plugin by using md import -i. So in order to modify the info.plist and schema files, you have to understand what UTRs are. So um, macOS defines file types by UTIs, and so they call it a uniform type identifier. And so on macOS, if you use UT type or MDLS on a specific file, similar to how on other operating systems you might use the file utility to get more information out of file, on macOS you can use this just to get the type information about a specific file. So some examples, a JPEG or an image file is a public.jpg UT type. A text file is public.text. But then also there's UT types defined by various vendors. So like Adobe files are com.adobe.pdf. Word documents files are com.microsoft Word doc. And then there's also for any data that's not defined by a UT type is just put into an overall what's called a dynamic type. And so that's this DYN that you're seeing. And so anytime some data doesn't fall into like a particular category, it will be labeled DYN, and then there's like this opaque hash that's assigned to it. So that's per computer. So looking at PNGs, for example, you can see the UT type is public.png, and then there's this content type tree. So image, data, item, and content is what defines, they're like subtypes of public.png. And so something to know about those dynamic types, it does change between machines. Um, and so we were talking about, like, from an exploitation perspective, if I was a really motivated attacker, all I would have to do to try and leak those dynamic type files is I would have to find that opaque hash, and then I could have to add that like as an exploitation component before I could use it to leak dynamic type information. But most of this information that's being parsed by Spotlight is known UTI. So because it's known type information, it's already going to be parsed. Additionally, something that we found in our research was that since the plugin is not signed, we don't actually have to recompile it in Xcode. We can just make modifications to this, and then it would just automatically be reloaded. So um, that again makes it kind of like a dangerous area for attackers because they're able to, if they're able to get onto an endpoint, they're potentially able to quickly modify the exploit to get even more information. All right, so now putting all together, this was our exploit, and I'm going to do a demo. So I hope you can see it. I know it's a little small. I'll zoom in. But you can see it says we tried to ls, and so you can see it says operation not permitted. And this is because we were trying to access the photos logger information, which again is TCC protected. But then when we run our exploit code, and this is just code to run our plugin, we can see that we're actually now leaking JPEG information. So even though from the terminal I'm not supposed to be able to access photos information, I did not grant full disk access by invoking this plugin, we are able to leak that information. So what are the implications of this? Well, I showed you all of the data that is stored on your machine by Apple Intelligence and by those services on your machine. So that means that an attacker, by leveraging this TCC bypass, can point to, the photos library, or can point to um, those Apple Intelligence databases and actually leak that information. Um, so they can even leak like the TCC database of other binaries and maybe find out other binaries that they should target permissions wise. So it's just really something where any information that's supposed to be protected and supposed to be safe on your machine is no longer safe because of this bypass. So as defenders, you're probably wondering, what are some detection opportunities for me? And so something that you want to be aware of is this is a constantly changing attack surface, and because Spotlight has been exploited so many times in the past, it is a little bit more difficult to detect. But there are things that you can still do. So some low-hanging fruit would be looking for the invocation of MD import, and you can just, look for MD import without any parameters, but you can also look for it with parameters like TAC-I. So there's like 4 different parameters that I think are kind of important that I wrote a detection for. And then some medium hanging fruit would be maybe looking for unsigned or ad hoc signed bundles. If you see any like new plugins that could be potentially suspicious, because when you think about it, like there's really not necessarily like a reason for there to be suddenly new parsers or new Spotlight plugins unless there's like an entirely new data type, which is pretty rare. Like Apple, unless they're adding some like brand new system service, or maybe you downloaded like an application that needs to leverage that caching, then I could see um, that could be a reason. But again, that's something to think about because you don't necessarily want to give access just because you downloaded an application from the internet. It's like, well, what is this application and why are you trusting it? And then why are you trusting it with access to your data? Um, Something else to look for would be anomalous editing of MD importer schemas. So like if there's an existing plugin on a machine and maybe suddenly it's parsing new types of data like that info plist file or schema.xml changes, that could be something. um, and so just another thing, you want to make sure that your box is patched and that your endpoint user boxes are patched. That's the best way to protect yourself against any exploits. And exploits like this, because luckily all of the CVEs that I talked about all came from researchers who disclosed to Apple and they didn't publicly present on them until Apple patched it. So as admins, Intune admins can leverage Intune to require that machines are updated in a certain amount of time. So you can prevent people from accessing your corporate infrastructure without being on the latest version of macOS. So make sure that you're implementing policies like that to keep your users protected. So here's just 2 detections that I think could be really helpful for you. And so you're going to go to device process events because that it has access to a lot of like macOS telemetry. And so if you look at process command line contains MD import, and if you just stopped there, that would just be any invocation of MD import. And that could, of course, give you benign instances, but also potentially malicious. So depending on how many you have, that's a good place to start. And then if you want to select out for only certain invocations, you can look at the, TAC R, TAC I, TAC T, and TAC L. And so that's all various invocations of MD import. Um, and so I think those are like some of the most common ones, and they have to do with like reloading MD import and then also forcing a specific file to be parsed. So that's where that could be useful. Another thing that you can do is just monitor Spotlight activity over time. So if you have this, just really short query, device process events, where a file name is MD worker or MD worker shared, I did this over a 30-day timeline, and I can actually see like when I added a new Spotlight plugin because I was testing this research, and you can see that those data spikes. So looking at those spikes and then isolating down to specific users could help you detect malicious activity. So with all that being said, to kind of summarize, um, first of all, make sure that your machines are patched. But with the rise of AI, privacy implications become increasingly dire. And this is because we have all these amazing agentic solutions that are now accessing these apps and some of this data. So it's just something to keep in mind, because we're leveraging these things to make our lives more convenient and get even more work done, and hunt these threat actors. But threat actors are also going to be leveraging these different agents. And so when it comes to protecting private or sensitive information, sandboxing might not be enough. TCC is not enough, because it is bypassed so easily. And Apple actually has announced that they're increasing the bounty on TCC bypasses because they're taking this so seriously. So really cool that information has come out, because that means that researchers, white hat researchers, are going to be finding these bypasses and reporting these to Apple. And so we think that it's a lot of it is like a design issue, lack of digital signature enforcement of these Spotlight plugins. So maybe seeing like more signing, only signed plugins allowed, something like that. That could be something to help mitigate stuff like this. And because TCC is so complex, and well, Spotlight is so complex, variant analysis is tough, because I think probably over the last 10 years, there's been at least 10 Spotlight exploits. So it can be difficult to patch this. And so it's something that you just want to monitor, because you can't necessarily rely on a patch when it comes to O-Day. So, and with that, thank you. And I didn't see a whole lot of questions in the chat, but I would love to take questions.
That was amazing, Christine, and I'm sure that they will keep coming in. So folks did ask about any prior articles, publications that they could check out. I think that this is new material being presented from the Microsoft side. So the fact that we got approval, again, this is based on attendee feedback. So please do submit that 3-minute post-event survey, because it is it's a pretty big deal to have our legit bona fide Microsoft security researchers join us to present all of their investigations, their analyses. And then ultimately, if you're asking the right questions, you get some recommendations. You can get to pick their brain. So it is not trivial to be joined today by Christine. I have a question, if I may ask it, Christine. Okay, I will have
Absolutely.
a number of them, but I will begin with the first one. From your perspective, what is the most overlooked or dismissed signal from the defender point of view, not the defender stack, but from a blue team perspective?
Yeah, you know what? I think that we don't pay enough attention to the fact that users will just kind of click things, and there's a lot of things that pop up that people don't understand. Um, and even ourselves, like sometimes you're kind of in it, you're focusing, and you don't notice things. So actually, I feel like I might have accidentally deleted a slide, that I'm gonna like just copy in really quick and add back, because I think this is kind of related to your question. So let me see if I can like live edit and if it will come up. I'm just gonna paste this slide in and see what happens. Um, okay, going back to Teams.
We got a comment, good stuff, a lot more to go learn about now. Again, this is not you can share other comments and feedback. But I think, again, to be very candid, folks don't typically get to see Microsoft security researchers presenting beyond our immediate stack necessarily, and really be research focused. I know that this is such a huge initiative that Sam and I care a lot about, getting that technical content out there for our global defenders. Cybersecurity is a team sport, regardless of your stack. Christine, are you sharing the slide that you wanted to?
So I
Okay,
pasted a slide in, but I'm not seeing it pop up. So I'm going to just go back in the deck. Um, but there's another, but it's kind of related. So I'll just go back to this pop-up, but you'll see pop-ups like this, or you'll see something similar where it's like, would you like to give this app access to your photos? And so I think these pop-ups are maybe not even like thought about, because you're like, oh well, like the user would say yes or no, but like maybe they downloaded some app, like maybe it's an AI app, right? um some AI app, and they're like, yeah, I want to give it access to my photos so it can like make a really cool avatar of me. But we just showed that your photos, don't just have like your picture, it also has like your home address, lat long. It has like just so much metadata. So I think that defenders need to think about, you can't just trust that the user is going to make the right decision. And it's not their fault because
right.
they're not thinking about all of these implications. We don't realize that all of this metadata is contained within our data.
Absolutely. Wow. I mean, fatigue is real across the board, right?
Yes.
And it's not their scope, right? That everybody has their position to play, and their function. Out of curiosity, kind of dovetailing nicely to my next question, from your perspective, how can business leaders best support their cybersecurity teams to defend effectively against these kinds of attacks?
Yeah, I think, giving their teams time to interact with the community is such a good way to help them stay on the bleeding edge, because oftentimes, conference presentations or just like being in a room with people who are experts on something can lead to findings. Like, actually, I just was at a conference and somebody mentioned um, a particular app used by DPRK IT workers, and I was like, oh, are we looking for this? And then it was able to kick off an investigation, and it was a new finding, and it was all because it's, you're interfacing with other people. So whether that's giving them time to like, be on the internet and just do OSINT searching, or to interface with other researchers, I think coming to this talk is awesome because now you're learning something, and giving your teams bandwidth to come to talks like this is a great way to keep them on the bleeding edge and help them just like stay up to date, because the attacker's constantly changing.
Absolutely right. So leveraging the community aspect, because cyber, it's not just a team sport. I mean, we are passionate about what we do, and I've never met somebody who is a true cyber practitioner who ever declined to be of service, to be helpful, to share their expertise, and more than that, to help you understand the actual framework for approaching a problem. So that's spot on, for sure. In terms of like what's next, or what folks should be keeping top of mind, do you have a bit of a forecast for how you anticipate these sorts of attacks might evolve?
That's a really good question. I think sometimes it can be like a difficult thing to understand how the threat landscape is going to change, only because it all depends on how the architecture changes. So like Apple has just introduced MTE, which is like memory tagging. I think it's like memory tagging extensions or something, but it's basically a new way to protect memory. So by introducing these new architectural components, they're trying to eliminate entire classes of bugs, which is that is what normally shifts the attacker's target, because it's like whatever they're trying to do, they can't do anymore because that entire class of exploit just like is not possible. So MTE is so new that we don't really know like what the implications are yet. But I think by looking at macOS 26, that's going to kind of see what's not possible anymore. And then then everybody's going to be looking for like the other cracks, if that makes sense.
For sure. You've blown my mind. You've impressed the the crowd for sure. I can't wait for you to return. I am going to get a slide on screen to kind of bring us home, close us out, but I wanted to make space for Sam, my co-host, co-creator for the series. Any thoughts from you? Sam leads the North American operations for our first party managed security service within Microsoft, Defender Experts. So Sam, if anybody knows how to get under the hood and get technical, it is Samantha Gardner.
All right, it's a big lead in, but I love it. I will sit here and say this. One thing that I love, whether it's the detections that Christine highlighted, and also just the full narrative, exploiting trust. It's pretty innocuous what they're asking for, the permissions that they're asking for. And for us as users, we just want it to work. We want our pictures to upload, or we want our phone to connect, right? And arbitrary speaking, they're asking for more and more privileges. And for us, we just want it to work. We're gonna accept, right? But people do not understand the magnitude of accepting such permissions. That's the additional contextual information that's provided, right? The metadata, which Christine said, was absolutely correct, right? But one of the things I love about the defensive strategy that hasn't changed is knowing your landscape, your environment, right? Understanding what activity look like, baselining, right? Whether it's your user activity, your programs that's running. Those are the things that allow you to find those needle in the haystacks, right? But also to see where the actor or certain attackers are trying to hide in the noise. And so the tipping point that I love about this in the defensive piece of the HQs is allowing you to see or actually correlate patterns in activity for you to spotlight and then dig deeper into to investigate, right? So as you're going through and you're looking at your environment, if you have any questions, leverage all of these opportunities to reach out to us and ask the defender. That's the beauty of this. So thank you so much, Christine, for this.
Thank you for having me. This was really great. It was fun to get to show people kind of what we're working on.
And stay tuned for the blog post, right? You're working on a sidecar instance, right? You have the technical article already that was published past summer, and now you'll have a complement to the session you presented today. So I'm really looking forward to it. Awesome. All right. Thank you so much, everyone. Don't forget to submit the survey for early access to the slides and the video recording. We will catch you next month. And also shout out to our MISA partner ecosystem. We are hoping to assemble a panel in the upcoming months where we can do even more technical deep dives across internal Microsoft and our esteemed partners that we work so closely with. All right. Thank you, everybody. See you next time.